derivation of the length equation, let's draw the principal axis where we're going to put our lens on. So using converging lens, I'm going to draw the converging lens now. That's a converging lens. And I'm going to draw a vertical axis through the converging lens, through the center of the converging lens. And that is the principal axis, the x-axis, and the y-axis is the vertical axis. So that's the vertical axis. Now I'm going to locate the focal point, which is symmetrical on both sides of the lens. Using the sign convention, the vertical axis is 0, to the right is positive, and to the left is negative. And the principal axis is 0. Above is positive, and below is negative. And now I'm going to write F is the focal length. And the object lens placed in front of the lens. And the arrow indicates the head of the lens, the height HO of the lens, and I'm drawing a ray of light from the object to the lens. And that point hitting the lens, we go through the focal point. And so that's the ray of light coming from the object to the lens through the focal point. Now, with the lens I'm using, this is a converging lens. That's converging. Lens, which means convex lens. That's another name for converging. And which means it focuses to it converges to a point. And the light coming from the head through the center of the lens will meet where it crosses the first line, that's the point, and the image is formed, and the image is inverted, real and inverted, and the image height is HI, and the distance from the object to the lens is U. The distance from the object to the lens is U, and the distance from the image to the lens and that's V. So that's the distance from the image to the lens. And the focal point length is F. That's the focal point length. And V for the image length from the lens. And the difference between V and F is V minus F. That's between the focal point and the image. And so let's identify similar triangle. So I'm drawing the first triangle I'm looking at in red. So that's the first angle, first triangle I'm looking at, drawing that in red. And then I'm going to draw the second triangle I'm looking at, comparing to in blue. And these triangles are similar to each other because they have a vertically opposite angle. And here's the vertical opposite angle between the two. That means they're equal. And therefore, HI, the image height, over HO, the object height, will be equal to, and that's negative for the image height, will be equal to U over V, and HI over HO will be equal to V over U, because the two minuses cancel out. And therefore, that is the magnification M. And the second triangle I'm going to look at is the one I'm drawing in yellow. The two triangles I'm going to look at, I'm drawing one of them in yellow. And then the second one will be drawn. Let's just shade the first one first. And after shading that, I'm going to shade the second one in red. So that's the second triangle I'm looking at. Okay, I'm going to compare the image object height and the image height, because the two triangles are similar, minus HI over HO. And the base is V minus F over F. Now I'm going to compare the two together, which is U over V over U equals to V minus F over F. Now if I cross multiply, I'm going to get VF equals to minus U open bracket V minus F close bracket, and expanding the right hand side, VF will be equal to minus UV plus VUF. And if I take it to the right hand side, I'll write VF equals to minus UV plus UF. If I divide both sides by UVF, now I need to cancel out VF on top. We cancel out VF below, and UV on top, UV below, and UF on top, UF below. Now I have 1 over U equal to minus 1 over F plus 1 over V. And therefore, 1 over f is equal to, if I move 1 over u to the right, 1 over v minus 1 over u. And this is the standard equation with sign convection taken into account. Without the sign convention, 1 over f is equal to 1 over v plus 1 over u. Now, this is without the sign convention taken into account. But remember also magnification as well. Magnification will be equal to, as m equals to v over u, which is also equal to hi over ho. And that's the magnification. That's the magnification.